Hello friends and my dear students, I welcome you all to my channel. If you are new to this channel or not yet subscribed, I will highly suggest and request you that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. This is part 3 video on the chapter ratio and proportion. If you have not watched the previous two videos, part 1 and part 2 on the chapter ratio and proportion, I will highly suggest that you watch them first to get a good understanding of about the ratio that we have discussed in part 1, and in part 2 I have solved all the problems on ratio from exercise 8a. So I highly suggest that you first watch those two videos and then continue watching this video. In this video I will discuss about proportion, its terms, and how it is related to ratios. I will discuss the concepts with some small examples for the clarity of the concept, and will also solve all the problems of exercise 8b. So this video is part of my playlist CBSE Mathematics Class 7 following the textbook of author RS Aggarwal. So let's get started with this video. Okay, so as usual I have my rough notes prepared on proportion on the left hand side, and on the right hand side I will discuss any concepts and I will solve the problems from exercise 8b. Okay, so what is a proportion? So we have already discussed what is a ratio. Ratio is by ratio is a measure of comparison of two similar quantity, and it is defined as the fraction a by b, where a and b are the two quantities of same kind. So we know that a and b ratio, a and b are two quantities. We know that a is to b means the ratio between a and b, which is nothing but the quantity a divided by the quantity b. So this is a fraction. Okay, we know so we know ratio of two quantities of same kind and of same unit. The quantity a and b must be of same kind, and they must be in the same unit. Okay, now what is a proportion? Proportion deals with the comparison of two ratios. So it says, as per the definition in the textbook, it says that four numbers a, b, c, d are said to be in proportion if the ratio of a and b, that is a is to b, equals the ratio between c and d, that is c is to d. So that we have the ratio a is to b is nothing but a by b, and the ratio c is to d is nothing but c by d. So if a, b, c, d are in proportion, it will mean that the ratio a is to b equals to ratio c is to d. That eventually means a by b equals to c by d, and it is expressed is a colon b and double colon c colon d. So if let's say so if there are four numbers, four quantities x, y, z, and let's say u, and if these x, y, z, u, these quantities are in proportion, we say that the ratio of the first two terms, that is x and y, that is x is to y, this is the ratio of the first two terms, will be equal to the ratio of the last two terms, that is the third and fourth term, which is z is to u. Now we know that this is nothing but x by y, and this is nothing but z by u. So we say that x by y equals to z by u. So reversely, if you have x by y equals to z by u, then you can say that x, y, z, u are in proportion. Okay. Now, so this is now proportion. The two ratios are in proportion is expressed mathematically. The mathematically expressed or mathematical notation in this case is x is to y is the ratio between x and y, and this double colon we use to mean that equality of two ratios. So the left hand side of the double colon is x is to y, which is the ratio between x and y, and on the right hand side we have z is to u, the ratio between z and u. So this is the first ratio, this is the second ratio, and we say that we put these double colon symbol in between to mean that the ratio x is to y is equal to z is to u, ratio z is to u, and overall we say that x, y, z, u are in proportion. Okay. Now this is this whole thing, this thing is also read as in words it is read as x is to y as z is to u. It means that x is to y as z is to u, z is to u. It means that x is to y is equal to z is to u. Okay, so if you follow the notes that, so this thing I'm considering so if we are given that a colon b double colon c colon d, if this thing, this phrase means that the ratio a is to b is equal to ratio c is to d, or in other words a, b, c, d are in proportion. So if this is the case, we know that a by b will be equal to the two ratios will be equal, that is a by b equals to c by d. This means that if we do cross product, AD equals to BC. So these small things, small results you should keep in mind. Now, okay. Now, if A is to B is not equals to C and D, if A, let's take some other letters. Let's say X is to Y is given, if it is given that Z is to U, that the two ratios X is to Y and Z is to U, they are not equal. This implies that X, Y, Z, U are not in proportion. So conversely, we can say that if the two ratios are not equal, we say that the corresponding terms, that is X, Y, Z, U, are not in proportion. Now, one very important thing to understand is that, so in proportion we are basically comparing two ratios. So in comparison, in proportion we are comparing two ratios. So this is the mathematical notation. This means that the ratio A is to B and C is to D are equal. Now, ratio itself is a fraction. It has no unit. It has no unit. Please remember, the ratio itself is a fraction, and it has no unit. When quantity, we say that quantity A and B are in ratio X is to Y, when we say that X is to Y, then quantity A and B may have some unit, but the ratio X and Y, they will simply be numbers, pure numbers. They won't have any unit. So we say that 2 kg and 4 kg are in ratio 2 is to 4, which is equals to 1 is to 2. So in the ratio, they are the terms of pure numbers, but the actual quantity whose ratio we are given, those quantity may have some, they will have some unit, or they could be pure numbers, but they could also represent some quantity with some unit. So in the proportion, also we compare two ratios. So ratios have no units, but if it is said that quantity, if it is said that some quantity A, B, C, D are in proportion, if it is given that A, B, C, D are in proportion and A, B, C, D are some quantity, they have some units, like kgs, like length, centimeters, meters, there could be ages, then it has to be the case that it has to be this A comma B must have same unit. Only then the ratio A is to B will make sense. Also, these C comma D must have same unit. If ABCD are in proportion and ABCD quantity are given with some units, then A and B must be of same kind with same unit, and C and D must be of same kind and same unit. The A and B must be, A and B could be of one kind, like they could be in kgs, and C and D could be of other kind, like they could be in rupees or whatever, some other kind of quantity and other units. But C and D must be of same kind and same unit, and A and B must be of same kind and same unit. This thing you should keep in mind. Okay, now now if it is given that, if we have, so this was regarding 4 terms in proportion A, B, C, D. If A, B, C, D are in proportion, then we say that A is to B equals to C is to D. But if it is given that A colon B is proportional to B colon C, then we see that there are actually 3 terms, A, B and C, and B is common. So the concept is same. This also implies that A by B, the ratio A by B equals to B by C, and from here we say we get that AC, if we do cross product, we get AC equals to B square. So this one important formula you should remember, that for 3 terms, and also here ABC are in continued proportion. If you are given a proportion where we have 3 terms, and the second term of the first ratio is same as the first term of the second ratio, then we have 3 terms ABC, and ABC are said to be in continued proportion. Whereas in the first case ABCD, they are just said to be in proportion. Now, okay. Now, what about the units? If ABC are, if it is given that A quantity A, B, C are in continued proportion, some quantity is given, they are not pure numbers, but some quantity with some units. If it is given that ABC are in continued proportion, then all ABC, all the 3 quantities must have same unit. Because what ABC are in continued proportion means that A is to B is equal to B is to C. So in the first ratio, A and B must have the same kind and same unit, and also B and C must be of same kind and same unit. So this implies that all ABC must be of same kind and same unit. Okay. Now let's talk about some terms. There are some notations, some terms. So in the first kind of in the first proportion where we have 4 different terms A, B, C, D, the terms A, B, C, D are said to be respective terms, or A is known as the first term, B is known as the second term, C is known as the third term, and D is known as the fourth term. But there are some special names given to some of these terms. A and D, that is A is the leftmost term and D is the rightmost term. A and D are known as extremes, or they are known as extreme terms or extremes. Similarly, the middle 2 terms B and C, they are known as means or middle terms. They are known as means or middle terms. And D is also called the fourth proportional to A, B and C. D, the term D, last term, is known as the fourth proportional to A, B and C. And if we have a continued proportion, that is A is to B is equal to B is to C, then we say B, here B is known as the mean proportional or geometric mean between A and C. And C is known as the third proportional to A and B, and also fourth proportional to A, B and B. So these terms you have to remember for problem solving, because these terms will be used in the problems. So you must be aware of these terms. The important ones are that in the proportion of A is to B equals to C is to D, D is called the fourth proportional to ABC, B and C are the means, and A and D are the extremes. And for a continued proportion where we have A is to B equals to B is to C, B is the mean proportional or the geometric mean between A and C, or C is known as the third proportional to A and B. Okay, I think these are the concepts, more or less. I've covered all the concepts required to understand what a proportion is. And okay, so let's then solve the problems of exercise 8B. I hope you can see the problems. Let's solve the problems. If you have any questions regarding any doubts on the proportion, please do let me know. I will be pleased to address your queries. Okay, exercise B, question number 1. Show that it is asking, show that 30, 40, 30, 40, 45 and 60 are in proportion. Okay, so if they are in proportion, we know this will implies 30 is to 40 will be equal to 45 is to 60. Now this implies 30 is to 40 is nothing but 30 by 40. It must be equal to 45 if it is in proportion. If they are in proportion, we must have 30 by 40 equals to 45 by 60. Now this is 3 4, and if this 5, so 5 9 5 12 and 3 and 4, yeah. So we are having both sides 3 by 4 equals 3 by 4. So they are in proportion. We see that the ratio 30 is to 40 is equal to the ratio 45 is to 60. So here the first, second, so 30 is the first term, 40 is the second term, 45 is the third term, and 60 is the last term or the fourth term. Okay. Problem number 2, show that 36, 49, 6, 7 are not in proportion. These are easy questions, but still I am solving it for the sake of completeness. 36, 49, 6, 7 are not in proportion. So this is true, are not in proportion. So if they are in proportion, we must have if 36 is to 49, if let's use some proper notation. If they are in proportion, we must have 36 is to 49 equals to, that is double colon 6 is to 7. Now this will imply 36 by 49 equals to 6 by 7. Now 36 by 47 is in no way equal to 6 by 7, because 49 is divided by 7, but 7 does not divide 36. So false. This is false. 36 by 49 is not equals to 6 by 7. So they are not in proportion. Okay. Question number 3. So while I am solving the problems, you can pause the video and take screenshot for your reference. Okay. Question number 3 says, if it is given that if 2 is to 9 is in proportion with x is to 27, then find x. Okay. So this implies that 2 is to 9 equals 6 is to 27. If they are in proportion, this thing means, if this notation is used, it means that 2 is to 9 is in proportion, 2 is to 9 equals to x is to 27. Now this whole if box, the whatever you see inside the box, that actually means that 2, 9, x and 27 are in proportion. And so from that statement we can say that 2 is to 9 equals to x is to 27. Now this means 2 is to 9 ratio is nothing but 2 by 9, and we have 2 by 9 equals to x by 27. Now if we do cross product, this is nothing but two fractions, equality of two fractions, and we know that from two equality of two fractions we can do cross product and equate the products. So 27 into 2 equals 9x, or rather 9x. It's better to have the variables on the left hand side. 27 into 2, this implies x equals 27 into 2 by 9, and this is equals 6. So x is 6. Okay, let's do problem number 4. It says if 8 is to x is in proportion with 16 is to 35, then find x. Okay, so this implies if this is given, then 8 is to x equals 16 is to 35. This implies 8 is to x means 8 by x. This equals 16 by 35. Doing cross product, we get 16x equals 35 into 8. This implies x equals 35 multiplied by 8 by 16. This is 35 by 2. This is 35 by 2. Let me check if I did it correctly or not. 8 is to x given as equals to 16 is to 35. So 8 by x equals to 16 by 35, and 16x equals to 35 into 8. X equals to 35 into 8 by 16. Okay. Now question number 5. It's similar. If it is given 8x is to 35 is equal to 48 is to 60, then find x. So from the given fact we can say that x is to 35 is equal to 48 is to 60. This implies x by 35 equals 48 by 60. This implies doing cross product, we get 60x equals 48 into 35. This implies x equals 48 into 35 divided by 60. Okay, so 6 divides 60, 10, and this is 8, and 5, 7, 5, 2, 2, 4, so this is 28. So x is 28. Okay, now if you see any mistakes in my answer or any calculation, please do let me know in the comment section. I will appreciate that. 6, let's do problem number 6. Find the fourth proportional to the numbers. Okay, there are two parts. In a proportion, the first three numbers are given. So these are like A, B and C. We have to find D. So the standard way we proceed is that let the fourth proportional be x. So this implies x is to 36 is in proportion with 6 is to x. This implies x is to 36 equals 6 x is to x. This implies 8 by 36 equals 6 by x, and then doing cross product we get 8x equals 6 into 36. This implies x equals 6 into 36 divided by 8. Okay, so 9 divide 36 4 divides 36 by 9, 8 by 2, and 2 divides 6 by 3, so this is 27. So the fourth proportional is 27. So we get that okay, x is 7, so the fourth proportional is 27. Okay, there are three parts. Part 2 is the first three terms is given 5, 7 and 30. So let the fourth proportional be x. This implies 5 is to 7 will be in proportion with 30 is to x. This implies 5 is to 7 equals 30 is to x. This implies 5 by 7 equals 30 by x. Now doing cross product we get 5x equals 30 into 7. This implies x equals 30 into 7 by 5. This is 42. So x is the fourth proportional to 5, 7 and 30 is 42. Similarly, in the previous problem, the fourth proportional to 8, 36 and 6 is 27. Okay. Let's do part 3. Part 3 is 2.8, 14, 3.5. So let the fourth proportional be x. So this implies that 2.8 is to 14 is in proportion with 3.5 is to x. So this implies 2.8 is to 14 equals 3.5 is to x. This implies 2.8 by 14 equals 3.5 by x. Doing cross product we get 2.8x equals 3.5 into 14, and this implies x equals 3.5 into 14 divided by 2.8, and if we convert the decimals to fractions, we get this as 35 by 10 into 14 divided by 28 by 10. This is nothing but 35 into 14 divided by 28. So this is 35 by 2, and since the numbers in the numbers are given in decimals, it will be 17.5. So this is the fourth. 17.5 is the fourth proportional to 2.8, 14 and 17.5, 6, okay, 17.5, okay. Let's do problem number 7. It says that if 36, 54 and x are in continued proportion, find the value of x. So it is given that 36, 54 and x are in continued proportion. So basically it is given that 36, 54 is in ratio, is in proportion with 54 is to x. This is given. When 36, 54, x are in continued proportion, it means that it is given 36 is to 54 is in proportion with 54 is to x. Find x. Okay. So find x. Now we know that this implies 36 is to 54 equals 54 is to x. This implies 36 by 54 equals 54 by x. Now I am solving the problems with detailed steps so that you understand what is happening, and if you are well versed with the concepts and the formulas of ratio and proportion, you can directly apply the formula that if you know that if ABC are in continued proportion, then you know that directly that B square equals to A and C. You could apply this formula directly. Now I am solving the problem step by step so that you know exactly what is happening. So from here, if we do cross product, we get 36x equals 54 into 54. So this implies x equals 54 multiplied by 54 divided by 36. Now this is nothing but 54 multiplied by 54 divided by 6 into 6, and we can cancel this by 9, this by 9. So this is 81. X is 81. That is the x is 81. So we say that 36, 54 and 81 are in continued proportion. Okay. 8 is the similar problem. It is given that if 27, 36 and x are in continued proportion, find x. So it is given that 27 is to 36 is in proportion with is equal to the ratio 36 is to x. So 27, 36, x, if they are in continued proportion, it means that 27 is to 36 is equal to 36 is to x. So 27 is to 36 equals to 36 is to x. So this implies 27 by 36 equals 36 by x. So the direct formula for a continued proportion, if ABC are in continued proportion, we know that B square equals to AC, or B equals to root over AC. So from here we are doing cross product. By doing cross product, we know that 27 x equals 36 into 36. This implies x equals 36 into 36 divided by 27. Okay, so if we do the cancellation, 9, this is 3, this is 4, and this is 12, so this is 48. So x is 48. Okay, now let's do problem number 9. Find the third proportional to this. So this is a similar kind of problem like 7 and 8, but it has been given in a different form. So finding the third proportional to 8 and 12, it means that that third proportional 8, 12 and that third proportional are in continued proportion. So third proportional to two given numbers always means that continued proportion is happening. Okay, so part 1, find the third proportional to, okay, 8 and 12. Now 8 and 12, 8 and 12. Now I am solving this problem in a little different way. Let x be the third proportional to 8 and 12. This implies we know that so this implies basically 8 is to 12 is equal to 12 is to x, and this implies we know that 12 square, the term b is here 12 square equals to AC. A is 8 and C is x. C is the third proportional to A and B in a continued proportion. So in this case, in this problem, it has asked to find the third proportional which we have considered x. So we will have b square equals to AC. So b is 12. So 12 square equals to 8x. Now this implies x equals 12 square divided by 8. This is 12 into 12 divided by 8. This is 4, 2, 4, 3 and 2, 6. So this is 18. So the third proportional to 8 and 12 is 18. Is 18. Okay. There are 3 parts. Part 2 is 12. It has asked to find the third proportional to 12 and 18. So let x be the third proportional to 12 and 18. So this implies 12 is to 18 is equal to 18 is to x, and from here we directly apply the formula. So we applied the formula that if A, B, C are in continued proportion, this implies B square equals to A C. In this problem we can now say that 12x equals 18 square. This implies x equals 18 square by 12. This is 18 multiplied by 18 by 12, and now we have to do cancellation. 2, 6, 2, 6, 2, 9, 6, 3. So this is 27. So the third proportional to 12 and 18 is 27. Okay. Part 3 is 4.5, and it has asked to find the third proportional to 4.5 and 6. So let x be the fourth proportional to 4.5 and 6. This implies 4.5 is to 6, sorry, third proportion. It is asked to find the third proportion. So it is about continued proportion. So let x be the third proportional to 4.5 and 6. So this implies 4.5 is to 6 is equal to 6 is to x. Now this implies 4 using the direct formula AC equals to b square. So this is 4.5x equals to 6 square. This implies x equals 6 square by 4.5. This is 6 into 6 and 4.5 is 45 by 10. 45 by 10. This equals 6 into 6 into 10 divided by 45. So 5, 9, 5, 2 and 9 goes this 6 into 6 is 36. So 4. So this is 8. So the third proportional to 4.5 and 6 is 8. This was question 9. Okay, let's do question number 10. Let's do question number 10. If the third proportional to 7 and x is 28, find the value of x. So it is given that if the third proportional to 7 and x is 28, so 7, x and 28 are in continued proportion. This means it is given 7x to x is equal to x is to 28. Okay, so this implies using the direct formula b square equals to AC, we will have b square equals to AC, we will have x square equals to 7 into 28. Why? Because if it is given that ABC are in continued proportion, then b square equals AC. So this implies x equals root over 7 into 28. This is root over 7 into 7 into 4. This is 7 into 2, that is 14. So x is 14. Okay, let's do problem number 11. Find the mean proportional between. Now you have to be very familiar with the terms that it is using. So third proportional is always two numbers. In the problem 10, it asked the third proportional to some two numbers, and the mean proportional in this example, mean proportional is also related to continued proportion. So if ABC are in continued proportion, then the mean proportional is B. The mean proportional is B. So we have to find B. So find the mean proportional. It will always ask find the mean proportional between two numbers, not two given two numbers, but between two given numbers. So 6, it is asking to find the mean proportional between 6 and 24. Okay, so let x be the mean proportional. This means that we have 6 is to x is equals to x is to 24. This implies from the continued proportion formula b square equals to ac, we will have find the mean proportional between x and 24. If the third proportional to is 28, find the value of x. The third proportional to 7 and x is 28. That means it is third proportional is C. Okay. Okay, so it is asking, so let x be the mean proportional between 6 and 24. So we must have 6 is to x equal to x is to 24. So we must have, using the formula b square equals to ac, x square equals to 6 into 24. So this implies x equals to root over 6 into 24. This is root over 6 into 6 into 4. So this is 6 into 2, that is 12. So 12 is the mean proportional between 6 and 24. Okay. Part 2, 3 and 27. 3 and 27. So let x be the mean proportional. So this implies 3 is to x will be equal to x is to 27. Now using the direct formula of continued proportion, we get x square equals ac, b square equals to ac, b in this here is x, a is 3 and c is 27. So b square equals to ac. This implies x equals to root over 3 into 27. This is 3 into 3 into 9. This is 3 into 3, sorry, this is 3 into 3, yes, and this is 9. So x is, so the third proportional, so the mean proportional to 3 and 20, between 3 and 27 is 9. Okay. Part 3, between 0.4 and 0.9. So let x be the mean proportional. This implies 0.4 is to x will be equal to x is to 0.9, and using the formula b square equals to ac, we get x square equals to 0.4 multiplied by 0.9. This implies x equals root over 0.4 into 0.9. This is root over 4 into 9 by 100. 0.4 is 4 by 10 and 0.9 is 9 by 10. So in the numerator we will have 10 into 10. Now this is 2 into 3 by 10, 6 by 10. So this is 0.6. So 0.6 is the mean proportional between 0.4 and 0.9. Okay. Question number 12. Question number 12, it says, what number must be added to each of the numbers 5, 9, 7 and 12 to get the numbers which are in proportion? So it is asking what number we should add so to the given four numbers so that they will be in proportion. Okay, so let x be added to all the numbers. So this implies 5 plus x is to 9 plus x. This ratio will be equal to 7 plus x is to 12 plus x. So it is given, it is saying that if what numbers should be added to 5, 9, 7 and 12 so that they will be in proportion. So if we add x to all the numbers, the numbers becomes 5 plus x, 9 plus x, 7 plus x and 12 plus x. And if they are in proportion, we will have this result. So now this implies that 5 plus x is to 9 plus x equals to 7 plus x is to 12 plus x. So this implies 5 plus x divided by 9 plus x equals 7 plus x divided by 12 plus x. Now you have to do cross multiplication. Now all the terms have, these are algebraic expressions, and you must be familiar with the product of algebraic expressions like product of binomials, product of monomials and binomials, which you have studied. I have already covered the chapter algebraic expressions. If you have not watched my videos on algebraic expressions, then I highly suggest that you watch those videos. It will give you a good foundation on the chapter algebraic expressions. So now if you do the cross product, we get 12 plus x multiplied by 5 plus x equals 7 plus x multiplied by 9 plus x. Now if we open the brackets on both the sides using the distributive law of multiplication over addition, we get that 5 into 12 plus, not open the brackets yet, but if we just do the first in the product of two binomials, you will have to use the distributive law of multiplication over addition twice. So the first time I use the distributive law of multiplication over addition, I get 5 into 12 plus x into 12 plus x equals, similarly I will do on the right hand side, this is 7 plus x, 9 into 9 plus 7 plus x into x. Now I will open the brackets. By doing the product of the monomials and binomials, I get 60 plus 5x plus 12x plus x square equals 63 plus 9x plus 7x plus x square. Now I will simplify the algebraic expressions on both the sides by adding the like terms. So if I simplify the LHS left hand side, I get x square, 5x plus 12x is 17x, and I have 60. Similarly, the right hand side becomes x square plus 16x plus 63. Now I will bring all the terms, I will bring all the variable terms. So we are actually solving x, so we have to find x. So we will bring all the variable terms, that is terms containing x, to the left hand side and all the constant terms to the right hand side, and this becomes x square plus 17x minus x square minus 16x equals 63 minus 60. Now if I simplify the term on the left hand side, the expression, the algebraic expression on the left hand side, by adding all the like terms, I can see that minus x square cancels with x square, and 17x minus 16x is x, and the right hand side is 63 minus 60 is 3. So x is 3. Okay, let's do problem number 13. What number must be subtracted from each of the numbers 10, 12, 19, 24 to get numbers which are in proportion? So it's a similar kind of problem like the 12 one. I will not completely solve it. I will just do some few steps so that you get enough idea to solve it. So the numbers are 10, 12, 10, 12, 19 and 24. So these are the numbers given, and it is asking what to subtract. So let x be subtracted from the numbers. So the numbers becomes, so after subtracting, so the numbers becomes 10 minus x, 12 minus x, 19 minus x and 24 minus x. Now these are in proportion, So it is asking that what number need to be subtracted from all these numbers so that they will be in proportion. So if we subtract x from all of these numbers, we will have 10 minus x, 12 minus x, 19 minus x and 24 minus x are in proportion. This means 10 minus x is to 12 minus x will be equal to 19 minus x is to 24 minus x. This implies that 10 minus x divided by 12 minus x equals 19 minus x divided by 24 minus x. Now, so if you do cross multiplication, we will do cross product. We have to solve for x. We will do cross product, and this implies 24 minus x multiplied by 10 minus x equals 19 minus x multiplied by 12 minus x. Okay, let's solve it anyway. Since I'm solving all the problems, I mentioned that I will solve all the problems. Let's solve the problems to complete to get the answer. Now similarly, now here I have to use, so these are product of two binomials, but in the binomials we see there are negative terms. So I have to use the distributive law of multiplication over subtraction. So this becomes 24 minus x multiplied by 10 minus 24 minus x into x equals 19 minus x multiplied by 12 minus 19 minus x multiplied by x. Now I will open the brackets and do the products. I get 240 minus 10x minus 24x plus x square equals 19 into 12. 19 into 12 is 399. 19 into 12 is 19 into 12 is 38 and 19. So 228 minus 12x minus 19x plus x square. So this implies we have to simplify both the algebraic expressions on both sides, and we get, by adding the like terms, and we get 240, we get x square minus 34x plus 240 equals x square minus 31x plus 228. Now I will bring all the variable terms, that is terms containing x, to the left hand side and all the constant terms to the right hand side, and I get x square minus 34x minus x square plus 31x equals 228 minus 240. Now if I simplify the LHS algebraic expression on the left hand side by adding the like terms, I get x minus x square cancels, and I have minus 34x plus 31x, that is minus 3x equals 228 minus 240, that is minus 12. So minus 3x equals to minus 12. So x equals minus 12 divided by minus 3, that is 4. So x is 4. Okay. Let's do question number 14. It says that the scale of a map is 1:2 some big number. What is the actual distance between two towns if they are 4 centimeter apart on the map? What is the actual distance between two towns if they are 4 centimeter apart on the map? The scale of a map is 1:2 something. Now it is given that okay, so this is the scaling ratio. The scale is given a ratio, so this is a very big number, this is small number. Map is a small area, so this must be this is the actual distance, and this is the actual distance. This is the we can say distance in map. Why I am writing in a diagonal way, I don't know. Anyway, so this is what the scale of a map means. 1:2 a very big number. So the big number should be the actual distance. The actual distance in realistically in Earth, the actual distance, and the 1 has to be the distance in the map, because map is a very small, it's a kind of 1 meter by 1 meter sheet. Anyway, so this is the ratio. Now it is asking what is the actual distance between two towns if they are 4 centimeter apart on the map. Now we have to realize one thing is that distance, now whatever actual distance, let's say whatever actual distance YB, between any two cities, if the actual distance is Y, and if the corresponding distance in the map is X, it should mean that 1:2 this very big number should be equal to X:Y, where X is the if X is a distance between two cities in the map, and the corresponding actual distance is Y, then we must have this. So in the problem it is given that the actual distance between two towns, it is asking to find the actual distance between two towns if they are 4 centimeter apart on the map. So this X is given to be 4 centimeter, and we have to find this. Now okay, so let Y be the actual distance between the cities. So this implies that 4 is to, since 4 centimeter is the distance in the map, so 4 is to y will be equal to 1 is to this big number. This implies 4 by y equals 1 by this big number. This implies y equals this big number into 4. So this is this should be in centimeter. So this is 20 into 10 to the power 6 centimeter. Since 4 was given in, now please remember that in this problem units are concerned. This ratio 1 is to this big number, it will never have any, it won't have any units, because when two quantities which have some kind, which have some units, their ratio, in the ratio it is a fraction, we don't have any units. So 1 is to these 6 zeros, here there is no unit concerned, but in the problem we have been asked to find the distance between the two cities, actual distance between the two cities if they are 4 centimeter apart on the map. So we have to the actual distance will also be, we have to consider the actual distance in centimeters. So we have considered the actual distance to be by centimeter, and so now we can say that the ratio between the distance in map and the actual distance, which is 4 is to y, has to be equal to 1 is to this big number. So from here we get y as 20 into 10 to the power 6. Now please remember that actually we have considered y to be the actual distance between two cities in centimeter. So y we get, so the actual value, the unit of y will be centimeter. So this is 20 into 10 to the power 6 centimeter. This is nothing, okay. So 20 into 10 to the power 6 centimeter, and okay, so we have to convert this in kilometer, I guess. So we know that 1 meter equals 1 by 1000 kilometer, and 1 centimeter 1 centimeter equals 1 by 100 meter, 1 by 100 meter. Okay, so basically this is, if you divide 20 into 10 to the power 6, if you divide 20 into 10 to the power 6 by 100, we get this much meter. Now again, if we divide this thing by 1000, we get this much kilometer. Okay, so we have 5 zeros in the denominator and 6 zeros in the numerator, sorry, 10 to the power 6, and we have this is 20 into 10 to the power 6 divided by 10 to the power 5 kilometer, and obviously this is 200 kilometer. So the actual distance between the two cities is 200 kilometer. This was a little conceptual problem. An example is already solved in the textbook. So please try to understand the problem, how the real world problem is has been mapped has been connected with the concept of ratio and proportion. So the thing is that the ratio of a distance in the map is to the actual distance is given, which is 1:560, and you are asked to find the actual distance between two cities if its distance is 4 centimeter apart. So the ratio, the ratio, both the ratio has to be same, because so this is where the concept of proportion need to be applied. So if in the map, if it is given that 1:2, let's take some small, very small examples with small numbers. It's a 1:10. Then it means that in the map, whatever you see distance, actually is 10 times. So if in the map, so this is map. In the map, a unit distance is actually 10 distance in the actually. I mean, 1 unit distance in the map is equivalent to 10 unit distance in the real life. So if this is given, this is a ratio. Now, if you are given x units in the map and you are asked what will be the actual units in real life, in the world, in the earth, let's say that be y, then this ratio has to be equal to this ratio. This is the concept, and this is where the concept of proportion is coming. So the 1:10 has to be equal to x:y, or 1:10 x and y should be in proportion. So this means the 1/10 equals x by y, and using this formula you have to solve y. Okay, let's do problem number 15. Problem number 15 says, at a certain time, a tree 6 meter high casts a shadow of length 8 meters. So 16, a height of 6 meter is casting a shadow of length, let this be 8 meter. This is the shadow. Okay. At the same time, a pole casts a shadow of length 20 meters. So there is a pole. Let's say this is a pole of length. At the same time, a pole casts a shadow of length 20 meters. So the length of the pole is not given. So this is given. Its shadow is 20 meters. Now it has asked to find the height of the pole. So let's see if the height of the pole is x. Now what concept we need to apply? Now the concept is that if there is an object of height, if there is an object, let's say this is an object, this is an object, let's say this is an object of height h, and it is casting a shadow, let's say of length s. So the ratio h is to s will always be same for all objects. I mean, objects which have a height, this ratio, and some object which has a height and the length of its shadow will always have the same ratio as h is to s. Now, so this is the fundamental laws of shadow. I mean, it's a concept of light, concept of physics. I cannot explain that. So the concept is that the ratio of the height of the actual object and its shadow is always same at a particular time. This is important. At the same time, due to the position of the earth, due to the position of the sun, at the same time, the length, the height of any object and the length of its shadow, that ratio is always same. So this is the concept we have to apply. So since it is given at a certain time that tree 6 meter high casts the shadow of length 8 meters, and at the same time it is given that at the same time a pole casts a shadow of length 20 meters. So what will be the height of the pole? So if we consider ratio of object height and shadow is given to be 6:8, because 6 meter is the height. If the height of the tree is 6 meter and its length of the shadow is 8 meters, that means the ratio it has given that the ratio of any object of height h and its shadow of length s will be always 6:8 at a particular point of time at the same time. So now if we consider let the height of pole is x, this will imply, since it is talking about the same time, so the ratio of the height of the pole and its shadow is x is to shadow is given 20. So this has to be equal to 6:8, because 6:8 this ratio is fixed. It is same for all objects. I mean it's same for any objects, its height and the length of its shadow at the same time. So this implies x by 20 equals 6/8, and from here we say that doing cross multiplication, cross products, we say that 8x equals 20 into 6. This implies x equals 20 into 6/8. So this is 2, this is 5, this is 3, this is 15. So the height of the pole is 15 meter. Okay. So this brings to the end of solving all the problems of exercise 8b. Now I would like to discuss some additional thing is that please note that when it is said, so it is very much right to say that 2 kg, 4 kg, 3 rupees, rupees 3 and rupees 6 are in proportion. It is a correct statement. If this, so there are 4 quantities. The first 2 quantities are in kg, the units are in kg, and the last, third and fourth quantities are in rupees. Now if it is given that these 4 quantities are in proportion, then what we need to understand is that the ratio of the first 2 terms, the first 2 quantities, has to be equal to the ratio of the third and fourth quantity. But to find the ratio of the first 2 quantity, they must be of same kind and have same unit. Also, the ratio, to find the ratio of the third and the fourth quantity, they must be of same kind and they must be in the quantity given must be in same unit. So these 2 are in rupees and the first 2 are in kg. So we can clearly see that the ratio of the first 2 terms is 2:4 equals 1:2, and also the ratio of the third and fourth quantity, that is rupees 3 and rupees 6, is 3:6. This equals 1:2, and these 2 are equal. So they are in proportion. So please keep this thing in mind. Also, let's say if you are given that let's say 3 centimeter 1 meter 3 centimeter 1 meter 3 paisa and rupees 3, they are also in proportion. It is a correct statement if I say that 3 centimeter, 1 meter, 3 paisa, rupees 3 are in proportion. Why? Because the ratio between 3 centimeter, we have to first find the ratio between 3 centimeter. 3 centimeter is to 1 meter is equal to 3 centimeter equals to 1 meter is 100 centimeter. This I think I have given the figures wrong. 3 paisa, and I guess this should be 1 rupee. Sorry. Okay. So now 3 centimeter is to 1 meter. The ratio is equal to 3 centimeter. We have to convert both the units to the same unit. 3 centimeter is to 100 centimeter. This is equals to 3 by 100. And 3 paisa, I am saying P as paisa, is to rupee 1 equals 3 is to 100. 3p is to 100 paisa. This is equals 3 by 100. So they are equal. So we can say that 3 centimeter, 1 meter, 3 paisa, rupee 1 are in proportion. So please keep this thing in mind. If you are given 4 quantities, then and it is said that they are in proportion, then the first 2 quantity has to be of same kind in the same unit. If it is not already in the same unit, you have to convert them to same unit, and the third and fourth quantity also has to be of some other kind but same kind. May not be other kind, but some will also need to be in the same kind and have same unit. And if they are not already in the same unit, you have to convert them in the same unit and then find the ratio. Okay, so this was all about proportion and its connection with the ratio. This brings an end to the concept discussion of ratio and proportion. In the next 2 videos, in the next video I will solve the exercise 8C, which is objective MCQ questions, and then I will solve the test paper. So please stay tuned for the next 2 videos, and possibly after completing the MCQ and solving the test paper, I will prepare another 2 test paper 1 and test paper 2, as I do for all chapters. This will be MCQ questions, 15 MCQ in 45 minutes, and the questions will be taken. I will refer questions from external source, not from the textbook of author RS Aggarwal. It will be from various other source, and the question will be of little conceptual and tricky and hard. So those 2 test papers will finally give you a good foundation of concepts on the ratio and proportion, and a good practice of a wide range of a variety of problems. So with this I end this video. Thanks for watching. If this video was beneficial, then please like it, share it with your friends, and also once again please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. And so that is it for this video. Until the next video, take care and bye.